All right, guys, a lot of you guys have been asking lately about how to do dilations. And so dilations is just when something either gets bigger or smaller. And what you're going to do is you're going to multiply the coordinate point, the x or the y, by what the scale factor is. So if the scale factor is something that is bigger than 1, so any whole number like 2 or 3, but also something like 4/3, 4/3 is bigger than 1 because 3/3 is 1. A reduction, or it's going to get smaller in size if it's between 0 and 1. So anything like 1/2, 0.2, 0.7, which is like 7/10, all of that is smaller than 1, but also it's a positive, it's bigger than 0. So you can see here that it's your x times your scale factor or your y times your scale factor. So if we have these three coordinate points, we have C, A, T, so this one's going to spell out cat. So we have 2, -4, 1, -8, and we have T, which is at 0, 20. Our image, which is our new factor, is going to be, it's a scale factor of 3, so it's going to be bigger, which means it's going to be 3 times as large, okay? So when you think about that, 2 times 3 is 6, so this is 6, and then -4 times 3 is -12, so the new coordinate points are going to be at 6, -12. We're going to do the same thing for 1, so 1 times 3 is 3, -8 times 3 is -24, so we're going to be at 3, -24. And then the last one at 0, 20. 0 is a special number because when you multiply by 0, it doesn't change. So because this was at the origin, because all of these are taking place from the origin, this point does not change. But 20 times 3 becomes 60, so this is 0, 60. And I'm just going to write out that 20 times 3 is 60 so we can see where that comes from. So that was an example with just coordinate points with a scale factor, and we can see that all of these are 3 times bigger. So this one was an enlargement, because an enlargement is if the scale factor is greater than 1. This one over here, example 2, is going to be a reduction, because the scale factor here is 1/2. So I'm going to go ahead and plot ABC first. So 1, 2, 3, 4, 5, 0. 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. B. A. And then 4, 1, 2, 3, 4, 5 here, because it was a -5. Here's C. So here, we're going to take A, and this was -5, and if I multiply that by 1/2, this is -2.5, and then 0 times 1/2 is 0. So I'm actually going to go to -2.5, 0, and this is A prime because this was half the length, it's half the distance. So we have 1, 2 of these to get to here. B, we're going to do the same thing. 4 times 1/2 is 2, and then 5 times 1/2 again is 2.5. So this coordinate point is at 2, 2.5, so 1, 2.5. And this is B prime. C was also at 4, and then -5 times 1/2 is going to be -2.5. So over 2, but this time down 2.5, and this is C prime. So all of these are on the inside of the one that they had. None of these stayed in the same place, but the coordinate points shrunk equally. Okay. And then we're going to look at example 3 here for a minute. So example 3, we have a graph, and we have the coordinate points again, and it's going to be a scale factor of 5. So we have -1, -2, -2, 4, and -2, -2. And this is an enlargement because 5 is greater than 1, so it's going to be bigger. And all of these are going to be multiplied by 5, so we're going to multiply by 5. So -5, -10, because 1 times 5 is 5, 2 times 5 is 10. A negative times a positive is going to keep it negative. -2 times 5, -10. 4 times 5, which is 20. -2 times 5, -10. -2 times 5 is -10. So I'm going to plot all of these points because it wants us to graph the image. 1, 2, 3, 4, 5, down 10. And this was f prime. I'm going to go -10. We're just going to pretend that it's up there since we're off the grid. And then I'm going to go -10, -10. And we're going to call this one H prime. And it would look something like this, really, really super tall. And I know my points went off the grid, and that line is terrible, but we're okay with that. So dilations, we're just multiplying. It's either going to get bigger or smaller, and the bigger or smaller is going to depend on the scale factor. Scale factor greater than 1 gets bigger. Scale factor smaller than 1 gets smaller.